So today we're going to start adding and subtracting radicals, moving away from just simplifying and moving on to performing operations with our radicals. So no new vocab, but just some review on vocab we've already discussed. The index, remember, is the small number above the square root. So if I have the third root of something, 3 is my index. And the radicand is the number underneath. So something like the square root of 8, I would say that 8 is my radicand. So that we can describe these two things when we're actually learning how to add and subtract. So let's get right into it. Our key points are fairly short for this objective. So the first key point we need to find is to identify all like terms. So we're familiar with like terms, but usually we consider like terms being similar variables. We don't even have any variables in this objective. So we need to start thinking of like terms, and in this case, like means same index and same radicand. So we need the same little number and the same number underneath. And so if we look at example 1, we see that we have radical 5 and radical 5. Both of them are square roots, and they have the same number underneath the root, so we would consider these like terms. Once you've found your like terms, step 2 is to combine the coefficients. So 7 plus 2 is 9. We keep our terms the same, just as we would if we were adding variables. And that is our final answer. So adding is very similar to if I had something like 7x plus 2x. I would identify my like terms, combine my coefficients, and leave my terms as I found them. Same thing when we are working with similar radicals. So now the same thing with subtraction. I want to identify my like terms. I notice that I have a square root of 6 and a square root of 6. So they have the same index and the same number underneath the root. And here there's just one little variation, is that my coefficient looks like there's nothing in front. But similarly, if I had x and then minus 5x, I know that this is actually a hidden coefficient of 1. The same thing goes for our radicals. This is a secret and hidden coefficient of 1. So if I were to subtract 1 minus 5 would give me negative 4 radical 6. And that would be my final answer for this subtraction. So we can also see multiple terms. It's not just going to be 2 terms. We can have 3 terms, 4 terms. Right? So here, going through our same steps, we want to identify like terms. One quick tip is to always check the index. Right? If you're rushing through this, you could very quickly glance and say, oh, well, they're all radical 3, radical 3, radical 3. I can combine them. But are these truly like terms? No, they are not, because they do not have common index. Even though they have the same radicand, all of them have 3 underneath the root, they do not have the same index. So these are not all like terms. We do have 2 sets of like terms though. So here I have a like term, and here I have a like term. If it's helpful for you to divide each term up, like you may have learned last year when you were first learning how to combine like terms, by drawing the lines, drawing your lines in between the terms, make sure you keep the sign with the coefficient. So you can draw your lines, and that might help you divide this up a little bit more. So now I see that I have a positive 3 and a positive 6. So if I combine those 2 coefficients, I get 9. The 4th root of 3, the like term stays the same. The only thing I'm combining is my coefficients. And then negative 7 is just kind of by itself, and so I leave him by itself. And again, I cannot combine any further because I don't have any like terms. Alright, so these were mostly simplified radicals, and all we needed to do was combine. But we're not always going to have radicals that are just ready for us to combine. What happens when I need to do a little bit of work first? So the first step should always be check to see if all radicals are in simplest form. Right, so I check. I know that 2 is just going to be a factor of 2 and 1, and 2 is just going to be a factor of 2 and 1. So these are in simplest form, but I need to check for 8. So 8 I know is 4 times 2. 2 is prime, and 4 is 2 times 2. Since I'm taking a square root, I have negative 2 square root of 2 times 2 times 2. My index tells me that I need to be taking out groups of 2, and I do have a group of 2 that can come out. So this is actually the negative 2 that was already out there, the 2 that I pulled out, and then I have a 2 still remaining. And then I can simplify my coefficients by saying negative 2 times 2 is negative 4, the square root of 2. Now that I have my simplified term, now I want to go ahead and try to combine any like terms. So here I have 8, the square root of 2, plus 5, the square root of 2. Just bringing down those two terms that were already simplified. Now I can complete my steps as I was before. Once all radicals are in simplest form, step 2, I want to find like terms, and then finally combine coefficients. Combine my coefficients. So I do see that I have a square root of 2, a square root of 2, a square root of 2. Same index, same radicand, so I can combine these all up. If I need to draw my lines between my terms to help me break it apart, I have a negative 4 plus 8 plus 5, which is going to give me a 9, and then I keep my square root of 2, and that is my final answer. So yes, occasionally things will be set up for you just to combine, but you should always be double checking every radical to make sure it's in simplest form. It always needs to be in simplest form, and that's going to make your addition and subtraction a little bit easier. And the last thing we have is our self-check. Here we have 3 problems, which are practicing the addition and subtraction of our simplified radicals. Double check that you're going through your key points. Are all of the radicals simplified? And if they are, look for those common index, common radicands, and combine any coefficients that you can. Bring your answers in so that we can talk tomorrow.